Hey guys, it's Ben, and today I'm going to be walking through the Broker Hack the Box challenge. I just solved this one, and it was an interesting challenge. It is easy rated. It's an easy rated Linux box, but I thought the root flag was a lot harder than the user flag. The user flag's fairly straightforward, but yeah, the privilege escalation part is a little bit tricky. But yeah, let's dig into it. So we're going to start off with an nmap scan to enumerate ports and services and see if there's perhaps something to exploit. So the switches I'm going to use for this are TAC-SV for version service enumeration, TAC-SC for the default NSE scripts, TAC-N to not do a reverse DNS resolution, TAC-PN to not send a ping check. We can check that it's up and running, 10, 10, 11, 243. So we see it's pinging, so we don't need to do that. TAC-O to output as full thorough, and I also do T4 just to make it a bit more of a speedy output, so we don't have to wait as long while it scans. So I've already ran this command, and we've got it here, the output. So let's have a look at what we find. Cat full thorough. So there's a lot of stuff down here, and then there is a lot of ports open on this. We see there's an Apache MQ service, which I wasn't familiar with. I'm not too sure what it does. If we start at the beginning, we see there's SSH open on port 22. We see OpenSSH as the software running that. There is also nginx, so there's like an nginx web server, HTTP on port 80. And it looks like there's a error 401 unauthorized. Typically, you see these when there's HTTP authentication, where it pops you up with an authentication box. If you ignore that, or if it like nmap scans it, it will give you the error 401 unauthorized. There is also this MQTT port on 1883, which I've got no idea what this is. There's a 5672 AMQP as well. I'm not sure what this is. And then there's a few more HTTPs web servers. This one's running Jetty, and then we've got some other ones. It wasn't able to figure out this service. And then there's a Stomp protocol, and it looks like we're seeing this active MQ pop up a lot. So let's do some googling, right? Let's see what this active MQ is. So Apache ActiveMQ is an open source message broker, so I guess that's where we got the challenge name. It provides enterprise features, which in this case means fostering the communication from more than one client or server. It's written in Java, so we keep that in mind. And it looks like we've got a lot of ports relating to this. We don't see a specific version looking through this, and we can see some Java stuff here. We can't see a specific version of ActiveMQ from the nmap scan. We can see a version on the Jetty, so we could perhaps do a Google search for this. Perhaps there's a vulnerable version. Yeah, we've got sync. We can see what vulnerabilities there are. There's an information exposure, and there's a denial of service and another information exposure. So there's not very many high severity vulnerabilities for that. Maybe we'll look at that information disclosure if we don't find anything else to look into. However, a lot of these other ports are, we've got like this nginx, and we've got these ActiveMQ ports, so we'll have a look at those. I am just going to start off by adding this to my host file, so I'm going to go sudo vi etc hosts, and then we can see down here I have already added it to my host file because I've already done the challenge, so I can just reference the hostname broker.hackthebox instead of using this IP every time. So let's just check out a few of these ports. If you recall, on port 80 HTTP, it gave us a 401 authorization unauthorized error. So if we just visit this, we can see it's asking us to log in. I don't know the username or password. Perhaps you could do some googling, or you may take a guess, maybe something like admin. Let's just Google ActiveMQ default credentials, or perhaps Jetty default credentials, default credentials, and we can see the username and password, the default one, and configured in Jetty Real, is admin. So let's just give that a go. Right, let's see what happens if we go again. Admin, and it looks like this does work. Right, we've got we've authenticated in, and we've logged in. So let's just have a look around. There was a few other web servers which also gave these unauthorized 401 unauthorized, so perhaps this 8161 does a similar thing. Let's just give this one a go. Broker.HackTheBox 8161. Ask for credentials, admin. That also, we can also log in with those credentials. These look identical, so I'm just going to pick one and go with it. Let's see, there's the Manage Active MQ Broker. Let's click on this, and it takes us to this admin page, and it looks like we've got some version disclosure here. We've got the version of ActiveMQ being 5.15.15. So what you may want to do is we've got the version of ActiveMQ, you may want to do some, a bit like we did with the Jetty, look at this version online. So let's just do that, see if there's any vulnerabilities for this. So I'll do a little Google Doc, ActiveMQ, and maybe if we put exploit next to it. It looks like there's perhaps an unauthenticated remote code execution. We could also have a look on Searchsploit for ActiveMQ. We can see there are a few exploits here. We can see one's in Metasploit, which I'm not going to use Metasploit, and is actually not for the right version anyway, so it doesn't look like there's any remote RCs in here, so we'll go back to here, and I also like to put GitHub on the end. That often gets some good stuff. Did we get we'll see if we can find the CVE number, and you could also probably include that. That's the actual Metasploit module, and we can see it does some XML, and then it sends it. So if you wanted, we could probably recreate this proof of concept ourselves, but we'll see if we can find something somewhere else. So let's have a look at this one. See if we can find any, and it looks like the same XML things going on here. We do get a CVE here, I believe. So let's just check out the CVE. Does this take us to the, no. So we can see, look, the CVSS rating is very high, critical, basically 9.8. Yeah, and it's actually part of the OpenWire protocol. It's vulnerable to remote code execution. So this OpenWire protocol is somehow related. If we look back over here, we did see Apache OpenWire somewhere, OpenWire transport on 6161, so maybe one of the ports, this would perhaps be the vulnerable port, and this OpenWire is used by, Java OpenWire is used by Apache MQ. So we've got the CVE rating. We could try do a Google Doc on this and try find an exploit. We've got one thing there. We've also got another one there. It looks like this is a sudo shell, but we do have two proof of concepts. So I'm just going to try this one here. And what we'll do is we'll clone this repository. I'm going to go in my exploits directory. I'm going to git clone this to get all the proof of concept in here. I can go into this, and we've got this exploit. I always like to just subl exploit just so I can get, and I'll delete that, just so I can have a look at what's actually going on. So it's creating a class, XML server, and it's creating a HTTP server. It's serving XML content, so it looks alright. Let's just give it a go and see. If I go Python exploit, and let's do the tag H to see. So we have to supply the active MQ server or host name, the active MQ server port, which defaults to 6116, which is what we saw over here, 6116, and then the serve IP and the serve port. So this would be we'll be serving up that XML file over HTTP. That's why we're creating a HTTP server, and then I guess we're taking a request. We're making the web server make a request to our box to download the XML file, which will contain the payload. So let's have a go. Let's just run this with what we've got so far. We know the IP, hostname, broker. I'll put the IP there so it doesn't spoil it. The whole command, it shouldn't make a difference. 10.10.11.243. The port is the default port, 61616. The server IP is my VPN ton0 interface IP, which is hidden by by me, but we can see over there in the top right hand corner 10.10.16.4. So I'll put that one there, 10.10.16.4. The port, it should be alright using the default port. I don't think I've got anything on that port, so we can just run this. It does say target's not responding, but it looks like we've got a shell, so let's just run a command like ID, and we have command execution. We've got a shell. If you do like pwd to see the current directory, if I just go out, does it save its, it doesn't save its state of like the directory it's in. This isn't really a nice shell. It is a sudo shell, so I want to upgrade to like a fully functional reverse shell where I can move around directories. I've got a lot more freedom. So what I'm going to do is I'm going to go to rev shells, and I'm just going to get your basic, like the go-to bash reverse shell, revshells.com, 10.16.4. I'm going to, port 4444 is fine. This is the one I was on about. I'm going to get a listener going up here. I'll zoom this in a bit. So netcat listening on port 444, and then in our sudo shell I will put the payload for the proper reverse shell. I'll press enter on this, and we see we get a callback. So I can close that one down a bit more. I'll go like that. Over here, I can now upgrade this to a TTY shell. At the moment, it still doesn't have full functionality, so I'm going to use Python 3. Or if we don't know what version of Python it is, we can check which Python. It doesn't have that Python, and then Python 3. We can see it does use Python 3. So we use Python 3, and then we're going to import PTY, which is the Python module used to generate a TTY shell. And I'm going to spawn a bin bash TTY shell. And I've got my quotation marks wrong there. Bin bash. I cannot type. If I want to clear my screen, I will do this. It says the term environment variable isn't set, so we can export term equals to xterm, and now I can clear the screen. I've got a fully functional reverse shell. I can move around directories, and I can get the user flag. We can go into the home directory, and we can see there's the ActiveMQ user. The current user I'm running as is ActiveMQ, so I can cd into this ActiveMQ. What I did there, by the way, I did cd into AC, and then I tabbed. In this reverse shell it doesn't complete it, but it has actually completed it, so I can't see its ActiveMQ, but when I press tab and then enter, it does actually cd into the ActiveMQ directory. So yeah, that's fine. Anyway, the user flag's there. We can see it's owned by root and in the ActiveMQ group, and then we can see it's read and writable by root, and it's also readable by members of the ActiveMQ group. I am in the ActiveMQ group, so I'm able to read this. I'm not going to read this because I don't want to leak the flag, but yeah, you can read that. So that initial access, that user flag was fairly straightforward. The we'll go on to the privilege escalation part now. It was just a bit fiddly. It wasn't too hard, and you can get the flag really simply. However, if I wanted a reverse shell, this took me a little bit longer to get because it was quite fiddly setting it up, but you'll see what I'm on about. So when I go on a Linux box and I want to privilege escalate, before getting limpies out, there's a few basic checks I do just to see if I can get any quick wins. One of them is looking for any sudo binaries, so I can do a command like find, type F, I'm looking for files, with the perm, with the user, having the sudo bit set, so, and I can redirect all their permission denied errors, these twos, to dev null. These will find binaries which can run, run as the permission of the owner, which is root. None of these are your known malicious binaries. What you may want to do, if you weren't too sure if they were, I said known malicious binaries. Sorry, known privilege escalation vectors. That's what I should have said. They're not malicious, obviously. What you would want to do to check this if you weren't sure is go onto GTFO bins, and we've got a binary there, for example, gpassword. You may want to search gpassword, and you would see it doesn't turn up. If you did another command like su, it does have a sudo capability for privilege escalation, but not a suid. If you want to see the suid binaries, all of these are suid binaries, and they can be exploited. However, none of these binaries here are in that list. I know that with experience. The other check I would do, apart from checking for suid binaries, is check the sudo capabilities I have with the current user. The command to do that is sudo tackl, and this basically, if this user has been may have been configured to run certain binaries or certain commands as root and restricted to run it without a password or with a password. So this is a good check to do. In this case, we can do sudo tackl. And we can see we do have a sudo capability. We can run the nginx binary without a password as root. So we can go like sudo user sbin nginx, and we don't have an issue. I don't get prompted for a password, we're all good. So is nginx in this list? Nginx. It's not. It probably could be added to this list now, to be honest, as it is possible to privilege escalate with it. It's not as quick and sharp and easy as a lot of these other GTFO bin privilege escalations. This takes a lot more steps, but and it's a lot more fiddly, but we can get there in the end. So we can run nginx, which is a web server. So what we could do, as we can run it as root, we could basically host a web server with the whole entire file system, and that would allow me to just go read the root flag. That would be the quickest and easiest way to do this. However, I want to get a fully functional reverse shell as root, so I'm not going to take the easy route. I'm going to get a fully functional reverse shell. So in nginx you can configure a webdav server. A webdav server is basically a HTTP server which has the functionality which allows you to upload files, delete files, whatever. It's commonly used, but we can configure a webdav server, and then we can upload our own files to the box. So that's the idea of it. But first, let's just create the webdav server. The nginx binary, if we do tackh, there is a configuration file. I'm not sure if this is the location of it, but there's a default configuration file which it reads the location from. Let's see if we can find it. I think it's either nginx.conf. Let's just find type f perm. Let's just check if it's this actually. ls tackla etc nginx.conf. So that is the file there. I cannot edit this file, so I cannot edit the default configuration to create a webdav server. However, I can pass it in the command line arguments with set configuration file. So that's what I'm going to do. I'm going to write this configuration file on my box here. I'm going to just say, I'm going to go out of here on my normal Kali machine just because it's a lot easier. I'm going to go out of here. I'm going to make a directory P for privilege escalation. I'm going to cd into privilege escalation, and then I'm going to vi my own config, so config.conf. Actually, I'll do this in subble, it'll be easier to read. You may want to have a look at what this nginx configuration file looks like, and we could nginx.conf. I'm just going to copy this nginx configuration file, and then we'll basically make some changes to it to make it work for our webdav configuration. So there's a lot of stuff here which is commented out. We can just get rid of this. We don't need it. The same with this here. We can get rid of that. Logging, SSL, we also don't want HTTPS or anything. We can get rid of that. There's certain stuff here which isn't really necessary. We can get rid of. Like, I don't think this is necessary here. Send file, nope. So what I do want to do, by default it will listen on port 80. I want to listen on a different port, and what you may want to do as well, one thing, is just look up webdav nginx configuration file. To be honest, when I originally did this, I did some googling around, struggled, and then I eventually had some help with ChatGPT to create the configuration file. But there's this dav methods directive which we have to add such that we can use webdav and use these HTTP methods to upload and do files. So I'm going to add this. I'm also I've got on my other screen the actual correct configuration so I can compare it because I can't remember off the top of my head. You have to set up a server such that we can configure the port to listen on, and apart from that it's nearly right. We'll do the server here. The port I'm going to listen on is 31337 Elite Hacker. The server name in this case is just broker.HackTheBox. There we go. And now this is where we'll do the webdav configuration here. We can also get rid of this. One thing I found useful when troubleshooting this, because I got a lot of errors with my configuration file, was to create an access log and an error log for purely webdav. This allows us to see the logs which are being produced if we have issues, so we can troubleshoot it a bit easier. And this isn't actually included in here. This is down here. There we go. But here we've got the webdav server, and we want to configure out where are we going to host it, right? This is basically going to be, there's going to be a directory at which the web server is hosted, where the files are accessible to, where we can upload the files. We'll use the location here to do that, and I'm just going to set this at the root directory. So I'm just going to say the root of the webdav server is literally just the top level directory on the Linux machine. Here we can set the dav methods like we saw before: put, delete, mcol, mkcol, copy, move. We can also set the permissions for the files which will be uploaded. So when we upload this using webdav, it's going to upload it to the Linux machine. What permissions will it set as? We can just set this, we can change this later, and we probably will, but just for example, we can just set this as read write group, read write, all read write. I believe that's what the permissions should look like. That's the syntax. And there's a few others things we can add. We don't want any HTTP authentication. That just it gives us another thing to make and deal, so I'm just going to get rid of that. Auth basic off, so we've got no HTTP authentication. Also, auto index on. I believe this allows us to see the file system when we actually like send a GET request to the web server. And then the last thing we need to do in the configuration file is set the user which the nginx web server will run as. And in this case that will be root, because we want to privilege escalate to root. So user root like this. Nice. So I think this looks alright. I don't think this is necessary here. I know the events part is necessary, but the contents of it isn't, so I can just get rid of that. We'll give this a go. We've got the config file here. What I'm going to do is I'm going to get a HTTP server on my Kali box running, and this will allow me to download the file onto the victim machine. I'm going to clear this. I'm going to make a directory, just temp, so I can do the work in there. And then I'm just going to use wget to download from my IP 10.10.16.4. The config is called, what did I call it? config.conf. There we go. What I can now do, like I said, we have sudo capabilities to run the nginx binary, nginx, and we had the option to pass the configuration in the command line arguments instead of passing it using the default like etc nginx location, and that means I can just specify the file path here, and we do need to actually give the full file path here for some reason. Active mq temp and then config.conf, and this runs, right? A check we can make just to see if the port is up and running. If you see back into the config file, we did choose to listen on port 31337. So we can do like an mmap scan on port 31337, port 31337 on broker.hackthebox, and we can see that port is now open. Before it wasn't open when we did our initial scan. So the web server is at least open. Let's just see if we can access it. Broker.hackthebox 31337. Nice, it's up and running. We've got full access to the file system. Now, if I wanted to, I could go to the root directory. I could get the root.txt flag. I'm not going to do that. Yeah. What I am going to do is I'm going to try get a fully functional reverse shell. There are probably a few ways to do this. I'll shout out another idea now. One of that is in the root directory, uploading a .ssh and a private key, public key. Basically, uploading SSH keys for the root user and then logging in via SSH. That is one way you could have done it. The other way you could do it is to upload a cron tab file. So in Linux, cron tabs are a bit like scheduled tasks which run at a set amount of time. They also can be defined to run under a certain user. So we can upload a cron tab file to do a certain action. If I just go on my box here, and I'll just go into PE, I'm going to copy etc cron tab and just put it here, cron tab. And now I've got the cron tab here. I'm going to edit this. This stuff here was for another blog or video, so I can get rid of this. And here I can choose the command I want to run. I want to run once every minute. So it will run every minute, and then it will run the command here. We could put a reverse shell here and get a fully functional reverse shell. We've got a lot of freedom. Now we've got command execution as root. Yeah, it's trivial. What you could do, some creative methods, is you could create like a sudo binary on like find which is vulnerable. It can be exploited for privileged escalation. I'm just going to do a reverse shell. Yeah, I'm just going to do a reverse shell. That's probably the easiest way. So I'm going to go bin bash taxi, and then the command I'm going to run is, and I'll get from the rev shells again, on port 443. And then I'll show you, because I had this issue when I did this originally, and we've got this here. So if we just check the etc cron tab here. So if I just cat etc cron tab, we can see there's no entry here. It's just the default cron tab. If I go ls-a etc cron tab, we can see it's got read write permissions, read permissions, read permissions. If I'm going to try upload this now. So I want to upload this using the WebDAV server, which we created using nginx and that configuration file. You can do this just in curl, right? You can choose the web endpoint you want to go to, which is broker.HackTheBox. The port, and this is 31337. And then tact is for put, and then you just supply the file you want to upload, in this case cron tab. I'm going to use tactVV to get some more verbose output. That will tell us the response code, if it was successful, etc. And I'll run this. We get a HTTP 201 created, and now if we run this ls-la again on etc cron tab, we'll see if it... Oh, I've done that totally wrong. What I've done here is I've uploaded it to the root level directory. So if I just go up, you'll see right to the top, we'll see there's the cron tab there. I uploaded it in the totally wrong place. That is fine. I'm going to go back to this and I'm going to upload it to etc cron tab. And I'll do this again, and now if I go ls-a etc cron tab, oh, and I'll get a reverse shell listener going, and that was on 443, I believe. Yep, 443. I've got the reverse shell listener going. This runs every minute, so we should be waiting about a minute, and I'll just clear this screen here. If I do ls-a etc cron tab, we can now see, and before, when we did this, originally when we did this, only root could write to this file. Before, the user and the groups both had read access. They weren't able to write. So I did this originally, and I waited for a bit over a minute, and it didn't work. And that is because in the nginx configuration file I set up here, I set the permissions for when it writes to the disk to have read-write permissions for all users. I just wondered, can you set like a sudo bit here? I've got no idea. That just sparked into my head then. Sorry, I paused for a bit. So what we're going to want to do is we want to make this read-write for root, and then read for all other users, and this will make this usable. Cron tab must not execute when it goes to do its every minute, or when it does its checks. It won't execute and it won't process because other users have write access, which, yeah, it's a vulnerability. So I'm going to download the configuration file again, because the configuration file was broke. I'm going to download that again. I'm going to go to ActiveMQ. I'm going to go to temp. There we go. I'm going to download http 10.10.16.4 config.conf. And I'm going to, should have deleted the old one, config.conf, move config.conf.1 to config.conf. There we go. Now if I just cat config.conf, we can see it does have the correct permissions. If I want to update nginx, I can do sudo user sbin nginx sreload, and then I'll supply the path here as well, home ActiveMQ temp config.conf. And it's got an issue here, couldn't find it. Let me just ls, it's disappeared for some reason, so I'll do this again. 10.10.16.4. Wait there, let me just check. I had this issue earlier. Did it delete the temp directory? It did. Maybe it's something which checks that. So let's just go into the temp directory, do this again quickly. 10.10.16.4 config.conf. We've got this, nice. We can now run sudo user user sbin nginx tac s reload tac c for the config file, which is in home active mq temp, and it's called config.conf. This worked, so we've now uploaded that new config file. If we go on ls-tac-la etc cron tab, just a reminder, it still has those write bits set, which means cron tab won't execute and it won't be able to run it. So what we're going to do is we're going to upload this again. I've uploaded it again. We get a different, we get an error this time. We don't get what we were expecting. Let's just check. Has this made a difference? etc cron tab. It has. It has updated actually. It now has the read bit set. So this is like the configuration for the permissions, which should work. So in a minute's time, we should hopefully see a reverse shell pop up on this screen here. I'll zoom in a bit and I'll move this over. There we go. Get rid of that. We'll wait for a second, and look, we've got a root shell. We go ID. Who am I running as root? We can cd to the root directory. Clear. Oh, export term equals xterm. Clear ls-tac-la. We can see the root.txt is there. We are running as root. We've got read access over it. So we've got a fully functional root shell. Like I said earlier, we could have got the root flag and cheated and got it a lot more easily than getting a fully functional reverse shell, but we've got the shell anyway. So yeah, that's this challenge done. I hope you've enjoyed, and I'll see you on the next one. Cheers.